Okay, we're going to take a look at the guided reading for Chapter 3, Section 2 about the sun. Our learning target is to explain how the sun generates energy through nuclear fusion. The pages in the book are 78 to 82. Later on, we'll work on a graph recording sunspots and solar flares, looking at how that could affect weather here on Earth. Let's get started. Where am I at? Right over here. All right, number one, the sun's energy comes from a process called nuclear fusion. There's another process called nuclear fission, which we use here on Earth at nuclear power plants, or like the nuclear bomb used nuclear fission. But on the sun, there's nuclear fusion. So what occurs in nuclear fusion? Hydrogen atoms join together to form helium atoms and produce energy. So it's so hot in the core of the sun that the hydrogen atoms are actually fused together. They're combined to make helium atoms. But when they are combined, that actually produces a huge amount of energy. And that's where the sun produces energy. Nuclear fusion occurs in the sun's center, or the core. Four layers of the sun's interior, from innermost to outermost. We start with the core in the center, then the radiation zone that's producing the fusion, and then the convection zone where the heat is rising off of the radiation zone. The sun's atmosphere, from innermost to outermost, there's the photosphere, the chromosphere, and the corona. Now, I believe photo and chromo are both word parts. Photo means light, chromo means color, maybe. 6, when you see a typical image of the sun, you're looking at the orange or yellow part. That's the photosphere. The chromosphere is the reddish glow visible just around the photosphere. So if you find a picture of the sun during a total solar eclipse, you could probably see that chromosphere, kind of the reddish part around the photosphere. And the corona, the moon blocks light from the photosphere, so the corona becomes visible when you're looking at a solar eclipse, total solar eclipse. The corona is kind of like the crown of the sun. It's like the pointy parts. When you draw a picture of the sun, you draw the pointy edges. That's the corona you're drawing. 9, corona sends out a stream of electrically charged particles called solar wind. So these particles travel through outer space, eventually reach Earth or other planets or other objects in space. That's solar wind. 3 features on or above the sun's surface are sunspots, prominences, and solar flares. And these 3 are kind of related. A sunspot is an area of gas on the sun's surface that is cooler than the gases around them. So it's kind of like a dark spot on the sun. Prominences are reddish loops of gas that link different parts of the sunspot region. So when there's these dark sunspot regions and then a giant loop of gas connects one to the other, that's a prominence. And then when those prominences erupt into like mega explosions, that's a solar flare, which sends a huge amount of solar wind. 14. When solar flares increase solar wind from the corona, what do they cause in Earth's upper atmosphere? Auroras or magnetic storms? So auroras are like the aurora borealis, which is a beautiful natural occurrence in the nighttime sky. And it's really beautiful, and it's a result of these solar flares from the sun. Magnetic storms, those could harm cell phone signals or satellites, so those could cause problems. So every once in a while you hear that there was a large amount of solar flares on the sun, so be careful on your cell phone, I guess. All right, make sure you do any corrections for this guided reading, and add any, or for every problem there should be a star or a check mark, and also add things to the class wiki.